Hey, year 10. Today we're working on factorising quadratics, this like x squared x in a number, when there's an a. And by an a, what I mean is a number out the front. I'll explain shortly why we call that an a. I want to start with one quite tricky example, just to recap what we did in our last lesson, and also show you a new method that you can use as well. So, what we've been doing is we've been looking at this last term 6, and we've been saying what are the factors of 6. You could have 6 and 1, or you could have 3 and 2. And then what we say to ourselves is there some way that I can use these numbers to make -5? Okay, just by adding or subtracting. I could do -6 plus 1, and that does give me -5. And I could do -3, take away 2 more. That also gives me this -5. So this is a case where there are two sets of factors that actually work. What I need to check is, are they still factors of +6? So in the case here, where you write out your factors, you check which ones make this middle term, but you have 2 options or even more than 2 options that work, you need to check, okay, so they definitely add to -5. Do they still multiply to get +6? Because I need to have it working for this expression. You'll notice here that I have -6 times, if I was to make this a times, -6 times +1, that would actually get me -6 as my last term. So even though it works for the middle term, it doesn't actually work for that last term as well. It's got to work for both. But in this case here, if I did -3 times -2, I do end up getting the +6 that I need it to be. So that's quite a tricky example where there were 2 sets of factors, but we need to narrow it down and get it as -3 and -2. Okay. Now, again, what we said at the end of last lesson, or kind of at the end of the first example, is you can get the actual x values, so saying x equals, by it's either the opposite of what's in here, so this would become +3 or +3, or it's what makes each bracket equal to 0. So again though, that would be 3 and this would be 2. The reason I've shown you that is because I'm going to show you another method for using the quadratic formula, okay? Another method for factorising where we can just use this formula and we're good to go. It's my favourite. All my mates who work in engineering and the sciences and applied mathematics swear by the quadratic formula. It's the thing they use the most. There are times when you still need to know how to factorise, especially if you're going into extension. If you're going into advanced, it's important. But honestly, if you can nail this quadratic formula, you can kind of get away with using this as well. So both need to learn, but I'm just going to quickly show you the quadratic formula now. The quadratic formula is, let me jump to my year 12 section for a second. It is written on your formula sheet. So from year 11 to year 12, any assessment we do, and in any exam, you're going to be given this quite lengthy formula sheet with all the stuff that we don't need you to remember, because remembering a formula isn't testing whether you can do something or not. And you'll notice on the very first page right here, under the functions heading, there's this big scary looking formula with like a square root, a plus minus, and a fraction. Okay, that is the quadratic formula. So the benefit of the quadratic formula is that you don't have to remember anything. It's written on your reference sheet. It is, and I always tell a story to remember it. I'll rip through this quickly because we don't need to focus on this right now. But you've got a negative boy. He can't decide yes or no. Does he go to this rad party? A square root is also called a radical. That's how it makes sense. But the boy was a square, so he missed out. He didn't go. And he missed out on 4 awesome chicks. But it's all alright because the party was all over by 2 a.m. And as it turns, 2 a.m. parties are super lame. So that is the quadratic formula. You don't even need to remember that stupid story because it's on your reference sheet right here. And if you're doing an exam, we're happy to give that to you in year 10 as well. Now what we can do we'll do the same example as up there. So we had x squared minus 5x plus 6. And now when we tried to factorize it, we almost got a little bit stuck because there was two sets of factors. What we can look at is this formula here, the quadratic formula, works when we have an a b, and a c. Okay, an a b, and a c. You notice there's an a b, and a c in the formula. We get all those from how this is written, all right? And it's always written in order with x squared, x, and then just the number. Our a is going to be the number in front of x squared. So the very first number. It could be positive, it could be negative. In this case, notice how there isn't one written. That means it is a 1. And then we move to the next spot. This is going to be the b, which is with x, our middle number. And that is going to be the negative 5. Make sure you grab the negative because it's that whole number in front of x. And finally, c is just going to be the number at the end, so just positive 6. Now, all you need to do to get your answer is grab your calculator, and you're just going to type in this equation here, but everywhere there's a b, you're going to pop in negative 5. Everywhere there's an a, you're going to pop in 1, and everywhere there's a c, you're going to pop in 6. Notice that when things are written together, like 4ac, that means 4 times a times c. One really useful tip that I would give you, whenever you're substituting anything, always use brackets around the thing you're substituting. So even though you would just type this straight into your calculator, I'll write out how I would be typing it into my calculator. So I'd hit negative, and then there's a b. So I'm going to write brackets, and then my b. Now this plus minus might be a little bit confusing at first. Start with just making it a plus. Square root. Now I've got a b squared. Again, picture the b, that is going to be your brackets with that b value, minus 4 times 1 times 6, all over 2 times 1. Now, yes, the brackets make it much more confusing to look at and to read and a bit of a pain to write, but it means your calculator won't get confused and you'll definitely get the right answer. Now, if you type all of that in, you're going to get one of two answers. It's either going to be 3 or negative 2. Pretty sure that one's 3, but I'm not going to type it in to check. The reason you get one answer there is, and notice, that is one of our x values. When we solve the equation, we get 3. Because back in our equation, it has this plus minus here, okay, and we just did plus, all you need to do is don't clear your calculator, use your arrow keys to go back up to this spot here and change that plus into a minus. Hit equals again, and you'll get your second x value. Now, I find that so much simpler because it works for any quadratic. And especially the ones I'm going to show you today, they have an a value, like a number out here. We have to do quite a bit of work to factorize that, whereas you can just use this method for any quadratic. The only issue with it is that you get this line here, you get the answer, you don't get it factorized like this. And sometimes when we do some like algebraic fraction stuff, really advanced stuff, you need to be able to get to this point. Okay, so factorizing, we need to know how to do it, but generally you can kind of get away with quadratic formula. So I would learn both. And by learning, you've got that on your reference sheet anyway. If you're working without a reference sheet, either write it down in your book or just Google it. It's the most popular formula in the world. You'll find it. Okay, so today we're looking at two things. We're looking at monic quadratics and non-monic quadratics. I've got two examples here for you. So a monic quadratic is called so because a, and now from that quadratic formula, remember we said a was the number out the front of x squared. We're going to use that same notation here because a is 1. So we call it a monic, okay? Mon or mo meaning 1, okay? because it has a 1 out the front. And they're all the examples that we've been doing so far. This example here with a 3 out the front is a non-monic because A is 3, or in other words, because A is not 1. Okay? So, I'm going to walk you through how to factorize non-monic quadratics, or in other words, quadratics where they don't have a 1 out the front. I'm going to go through a method that is a little bit tricky. I'm going to go through what I call the slip and slide method, which is kind of like my shortcut version for it, which you can remember and use. And then I'm also going to show you how to do it with the quadratic formula, because it's so much better and it's so much easier. And honestly, this slip and slide thing is so tricky. I would argue that 95% of maths teachers probably don't know how to factorize non-monic quadratics off the top of their head. Okay, normal quadratics, sure. Non-monics, so when there's a number out the front, I reckon most of them don't do it anyway, or if they do, they'd have to look it up. So you can really get away with, I'm going to show you how to do it, have a go, do it once or twice, have it in your book so we can go back to it, but then we can generally use the quadratic formula to get away with doing these kind of ones when it's not a 1 out the front. Okay, so the setup here is we have 2 sets of brackets, okay, and we know the firsts and we know the lasts, okay? The lasts are going to be these numbers here, and they are going to, same as last time, they're going to be 2 numbers that multiply to give 28. So you think, righto, numbers that multiply to give 28, they could be, what do we get? We could have 28 and 1, we could have 14 and 2, 7 and 4 would work. I think that's it. So they're my factors of 28. They're the numbers, okay, that are going to go here and here. One of these pairs, but we need to figure out which one. The other thing we know for sure is our firsts, okay? That's the first term in each bracket. We know that they're both x because we have an x squared. Now, they're going to be getting a 3 out the front, which means when you multiply this by this, the numbers in these boxes get you 3. Now, the only factors of 3 are 3 and 1. So one of these must be a 3, one of them must be a 1, okay? And we know that our factors are out of this list. The problem here is that if you were to expand this thing, when you multiply 3x by this and 1x by this, it changes from that typical FOIL setup. So we can't just use these factors to see do they make negative 25, because there's another step in the works and it doesn't work for us. So that's why we can't just use the whole backwards FOIL, or some people call it PSF. That doesn't work. So what I'm going to recommend is what I call the slip and slide method. And I by no means came up with this. I had a wicked teacher who showed me how to do it. I'm going to show you. I'm going to break it up into, I believe I've got 6 steps here ready. Okay. If you remember this, you can absolutely use it rest of your life in any exam, any test, and it's totally fine and valid. It's just a more streamlined way of doing what can be a disgusting process. Again though, we're going to go through this, we're going to grit, we're going to do a couple of questions. I'm not going to set you too much work on this. There isn't a maths-based task. And you have the quadratic formula to fall back on. So don't go into this lesson too stressed. Okay, slip and slide method. Step 1. Okay. Step 1, I need to figure out what is A times C. Now, A and C, remember from our quadratic formula, A is the number in front of x squared, B is the number in front of x, and C is the number at the end. Okay, so I need to figure out. Okay, slip and slide. The first thing we need to do is we need to identify that this is A, which is the number in front of x squared, this is B, and this is C. Okay, now step 1. We're kind of going to do 2 steps in one because they're very quick and simple, okay? We are going to get rid of this 3. Scoot him out of there, he's gone. But when we get rid of him, okay, we need to multiply him, that 3, by our C, our last term. So he multiplies over here instead, and you get 84. I'm going to write this as get rid of A and multiply A by C. Okay, that's our first step. We're a sixth of the way there. Step 2 is we're going to factorize our new equation, this one here. Okay, now it's easier said than done, but we'll have a go. What we're going to be doing is our normal method, where we look at our last term, we say, what are the factors of 84? I know I could have 84 and 1. I know I could have 42 and 2. I know I could have 21 and 4. I'm sure there's other options, but that's enough for now. Let's check these ones. So you're checking, and by the way, this is a gross example because I picked the worst one so I could give you some nicer examples later on. So now you're saying, right, with these numbers, same as we normally do, can I use them by adding and subtracting to get negative 25? Clearly that's not going to work with 84 and 1 or 42 and 2 because the numbers are going to be too big. But 21 and 4, if I had negative 21 and negative 4, that indeed gets me negative 25. So that means my factorized version is going to be negative 21 and negative 4. Okay. I told you this was gross. We're still going. The next step, it's quite a nice one. We're going to divide the constants. Now, a constant number is just a number without x. So it's just these numbers here, okay? We're going to divide the constant by that original A value, that 3, the one we multiplied by C. Now what we're going to do is we're going to divide each of these constant numbers by 3. Now step 4 is quite nice. What we're going to do is we're going to simplify any fractions that we can do. So you go 21 over 3. Does 3 go into 21? It does 7 times. And you could do that on your calculator too, just type in that fraction. But negative 4 over 3 doesn't simplify. I could write it as 1 1/3, but that doesn't do me any good. Okay, so I'm going to leave him there. Now step 5, okay, so far we multiplied A to the end, we factorized like normal, a little bit tricky, but we got there. We divided the constants by that A that we multiplied by at the start. And then at this point, we just simplified any fractions we could. Now we're going to do the slide. So we are going to slide any denominators up to their x value. So what that means is, this one's fine because there was no denominator, but here, this denominator of 3 is going to slide up to that x, and it's going to be 3x minus 4. And that's done. That is the factorized version of a non-monic quadratic. Oh, it's gross. Finally, step 6, if we would take this a little bit further, okay, this is for solving. So right now, factorizing is fine, but if you were going to solve it, okay, it'd still make bracket equals 0. So for this bracket here, that must be 7, because that makes that bracket equal to 0. And for this set of brackets here, you're saying, ooh, okay, so 3x minus 4, how do I make that equal to 0? And you've got a little equation to solve. You could just kind of guess it if you want to, but we're going to have to plus that 4 across, and then divide by this 3. Oh, sorry, so 4 over 3. Now, again, I know you're probably freaking out, but you don't necessarily need to have this. It is the nicest version I can think of for doing non-monic factorization. There it is, we've done it. Okay, we're gonna go through a couple more examples, but if you ever just needed to find the x values, you can always use this quadratic formula that's given to you on your reference sheet. And to show you what that would look like, all you need to say is, well, A was 3, B was negative 25, and C was 28, just from that equation there. And then you're just gonna pop those into the formula. Just make sure you pop brackets around each thing as you do, and you will get exactly the same answer. Okay, let's go through I think I've only got, I've got a couple more examples for you. Okay, we're gonna change this up in real time. I've got 2 examples here. What I would encourage you to do is have a go at factorizing these yourself. You can either use that slip and slide method we just went through. Feel free to rewind, or feel free to watch the first one, then try the second one. Or you can try the quadratic formula. I'm happy with either. If you want to use a quadratic formula, you can either Google it or again go back and just scribble it down, and it's fine. We're just going to go through these 2, and that's going to be the task for this week. So we've got 8x squared minus 19x plus 6. So if you want to have a go, pause it now, and then you can have a look through and make sure you did it all right. That's going to be my A, that's going to be my B, that's going to be my C. Step 1 is I get rid of the 8, but I multiply that 8 at the end, so by my C. Step 2 is to factorize that. So I say to myself, right, what are the factors of 48? It's 48 and 1, 24 and 2, what else? 16 and 3. And you can honestly start to use a bit of intuition here and say well, that doesn't work, that doesn't work. But 16 and 3, I can use those to make the number 19. And if you can make the number, you can usually jump to the answer. That must be negative 16 and negative 3. So that's going to be my factorization. Okay. Next step. I actually have to look this up because I've already forgotten. Then we need to divide by the A, which was 8 in this case. So it's going to be x minus 16 on 8 and x minus 3 on 8. And you could just jump straight to the answer here too. You could do the simplifying and then the sliding in one go, because I'm just going to simplify the fraction that can be. And then the next step is just to bring that 8 up so it's with the x. Just like that. Okay, cool. Now, if you were to solve that, which is an extra step, we're not necessarily doing solving yet, you would get x equals 2, 8x minus 3 equals 0. So what I'm doing here is I'm setting this equal to 0 because I need to figure this out. That one I can just jump straight to the answer for. Now I need to plus 3 across. I'm going to get 8x equals positive 3. And then I need to divide by 8. And I get x equals 3 on 8. If you did the quadratic formula method, you were going to get these answers here. And again, for 90% of the time, that's fine. But be aware, if you are doing this and just using quadratic formula all the time, there may be a question in your exam at some point that needs you to do the factorizing. Okay, the odds are low, but you still need to know how to do it, technically. Okay, we'll do one more here. Again, if you just watch that one, you want to have a quick go at this one on your own, you think you got steps down, pause it, have a crack, and then we'll go through it. So we've got A, B, C. Step 1 is I'm going to get rid of the A and multiply it at the end. I believe it's 72. Yes, okay, cool. And then I need to figure out my factors of 72 because I'm just going to factorize like normal. I could have 72 and 1. I'm going to stop writing those because clearly 72 and 1 is not going to get me 21, right? So you can start being a bit more logical about it. 36 and 2 isn't going to work either. What else might be a factor? What about 24 and 3? I definitely can use 24 and 3. I could have negative 24 plus 3, and that would get me negative 21. So my factorization must be negative 24 plus 3. Now step 3 is I'm going to divide by the number I got rid of at the start. I can't remember what it was. Was it an 8? Yes. Okay. Step 4, I'm going to simplify the one that I can simplify. And step 5, I can slide that 8 up from the denominator. Finally, if you want to do the solving, if it's just x with a number, then it's just the opposite, so just plus 3. If it's more than that, we need to write that equation equal to 0, and then we do like our year 7, year 8 equations. You got a minus 3, my pen doesn't work, so you get 8x equals negative 3, and then I've got to divide by 8. And I get x equals negative 3 over 8. And again, if you do the quadratic formula, you just get this here and this here. And you can just write those as your answer. You will not lose marking for doing all these steps. Okay, if you are still a bit confused, here are 6 that I've pre-prepared, okay, that are a bit trickier. If you want to have a go, they're here, go for it. But honestly, if you can do your normal factorizing and your normal expanding, that is dreaming. I'm beyond happy with that. This is just something we technically have to cover. I'd encourage you to have a look through it, maybe do 1 or 2, and maybe try using quadratic formula once or twice too, because that quadratic formula is definitely going to be useful. Okay, and that's your task for this week. If you finish this lesson, you're pretty happy with it, you're just going to leave it, you're done. Awesome.